Hey math kids, today we're going to talk about inverse functions, and we're going to look at how that shows up when we're talking about ordered pairs as well as tables. So this should be a quick video. Okay, so the idea is with a inverse function is we just switch the input and the output. And so if we're thinking of x as the input, and if we're thinking of y as the output, we just swap those. And so the inverse to this ordered pair is just 3, 2. We just swap places. Same reasoning over here. We get 6, -5. Just swap the x and the y. And then over here it's -2 and -1. So once again, with ordered pairs, we just switch the x and the y, or we switch the output and the input. Now we're going to use that same thinking with tables, because tables really are just a bunch of ordered pairs. So since I have a 1 here and a 4 here, I'm going to write 4, 1. So I just swapped the input and the output right there. Then I get 5, 2. And then I get 6, 3. Once again, swap the input and the output, or swap the x and the y. Now if I'm doing an inverse over here, I could even just write down all the y's in the x column, and then write down all the x's in the y column. Now it is important that you still have the 2 corresponding to the 5 and the -3 corresponding to the 7. We would not want to write -3, 2, 1, and then do 5, 7, 6. That doesn't work. We need these to still correspond. We just switch the ordered pairs. Now over here, we have a 5 and a 5. So it's going to look like we don't switch anything, but technically we're swapping the x and the y. And then we do the 1 and the -6. And then since these are both -2's, it's going to look like it doesn't swap again. If you need additional help, come to Math Lab. Until then, calculator.